Welcome students. Let us see AP Physics, Electricity and Magnetism latest change for 2024, and we will also discuss a question related to AP Physics C, Electricity and Magnetism, and we will continue a series of questions for your 2024 examination, right? So what are the latest change? So content wise there is no major change, but in the pattern of examination there is a considerable change. So let us see what are the changes. So as you have also gone through this website update, that now we will have 45 to 50 MCQs. Previously it was 35, now you will have 45 to 50 MCQ, and for this you will have time 90 minutes. Now previously it was 45 minutes, now you will have 90 minutes option, 90-minute time duration for objective questions, MCQ questions, and now you will have 4 options in place of 5 options. So what are the major change? Questions increase from 35 to 45 or 50, time change from 45 minutes to 90 minutes, options 5 options to 4 options, and the previously we have 3 FRQs, free response questions. Now we will have 4 free response questions. That's the major change. And for this we have the time now for 90 minutes. Previously it was 45 minutes. Now for this we will have 90 minutes. So this is the major change in examination pattern for 2024. And let us see one question regarding this AP Physics C, Electricity and Magnetism. So let us see. So this is a question, and this is the question of AP Physics C 2009, right? As you can see. So let us try to understand the question. So at the filament, electrons created at the filament at the left end of a tube. So this is a tube, and this is a filament. Just a minute. So this is filament. Okay, so electrons created at the filament at the left end of a tube represented above are accelerated through a voltage V0. So here electrons are created and they are accelerated through a potential difference V0. This is the accelerating potential and this is the V0, right? So and exit the tube. So till here electrons were in accelerating mode, and after this they are exit out from this accelerating zone. Now the electrons then move with a constant speed. It is obvious because after this tube, after this accelerating zone, there is no acceleration. So now the electron will have a constant speed. No acceleration, no force. That's the constant speed. See, since acceleration will be 0, so force will be 0 because F is equals to ma. Since no acceleration, no force, then no change in speed. That's the Newton's law. If there is no force, there is no change in velocity or speed. So now its speed will be constant when it exit out from this tube region, right? And before entering a region in which there is a uniform electric field. So from here to here, its speed is constant. Its direction will be same, speed will be same, because we assume also that there is no any gravitational force because electron has a very less mass. So in this region, there is no force at all. So its speed will be constant and acceleration will be 0. But so now electron is going to enter in a uniform electric field between two parallel plates separated by a distance d. Now this is distance d and these are the two plates between which there is a electric field. but we don't know the direction, right? Where it will be going upward, it will be going downward, we don't know. We are just getting the information of questions only. So now the electrons enter the field at point P. So now the electrons going to enter at this point, that is the point P, which is a distance y naught from the bottom plate. So it is indicating it's a y naught distance above the bottom plate, or you can say the height from bottom plate to point P is y naught, and are deflected towards the plate, towards that plate. And as you can see in the picture, this electron is deflected towards this bottom plate. Express your answer to the following in terms of V naught, D, and Y naught and fundamental constant. So this is the V naught, Y naught, D, and this is according in this diagram, this is also Y naught. Okay, so these are my given quantities. I can leave my answer in these terms also. Now the question is, I hope you have understood the question data, right? Calculate the speed of the electron as they exit the tube. As we know that if we accelerate an electron in a potential difference, it will have a kinetic energy, that is the E into V naught. This will have this much of kinetic energy, right? And we know that the kinetic energy can be written as half mv square. So this can be equated as E into V naught, right? So m is the mass of electron, we are talking about the electron, so we will take the mass of electron, that's a constant quantity. This E is the charge of electron, please don't be confused, and this V naught is the accelerating potential. So from here we can find V square is equals to 2 eV naught upon m of E, that's the mass of electron. So now we can find V, that is the velocity of this electron will be, or speed of this electron will be, under root 2 eV naught upon mass of electron. So this is the answer of first question, under root 2 mv naught, sorry, what it was, it was 2 eV naught upon me, 2 e v naught upon m of E. So this is the speed of the electron as they exit the tube. See, we directly get the speed at the end of this tubular length or accelerating length, right? Calculate the magnitude of the electric field required to cause the electron to land the distance y naught from the edge of the plate. See, from the edge of the plate, so that is this y naught. The question is saying about this y naught from the edge. This is the edge, from the edge of the plate. So we have to calculate the magnitude. See, we have to find only the magnitude, not the direction of the electric field required to cause the electrons to land the distance y naught from the edge of the plate. See, what will happen when electron enters in this electric field region? Now electron will experience some force. See, if the electron is deflecting downward, if the electron is deflecting downward, we can think that the electric field should be in upward direction. Then only electron will have a force in downward direction, that is the F is equals to QE. And since the electron has negative charge, so it indicates that its electric field should be in upward direction, so that its force will experience in downward direction, so it will deflect it downward. So we get the direction of electric field also, that it will be upward. So this is the direction of electric field. Now we have to find how much the magnitude of the electric field. See, this will follow a parabolic path, and we are interested in x direction. See, parabolic motion is a basically two-dimensional motion, so we can do our analysis in separate dimension also. So since we are interested, we have the information for horizontal direction, and we are interested to calculate something related to horizontal direction, we can assume the horizontal axis calculation, right? Or we can think like this also. There is one another view to think this. problem. See, time. Time is that quantity, as you can see, in time duration, a time duration in which this electron will fall down till point here, it will cover the horizontal distance y naught, this, and it will cover this vertical distance y naught also. Time will be same for both the direction, right? So we can find that time also. Let us calculate its time during which it will fall horizontally y naught distance as well as vertical y naught distance. Time will be same for both because it's a two-dimensional motion. So so now the interesting question is, from which axis or from which axis displacement we are able to find time easily. So I think in that direction in which there will be no acceleration. Please see, if you have any kind of motion going on, first please think about its acceleration. Acceleration is present or not? If it is present, it is constant or variable. If it is variable, it is time variable or displacement variable. So this is the very fundamental for kinematics. So we will select that dimension in which acceleration will be 0, so that my calculation will get easy. So in x-axis, or you can say along the x-axis or horizontal direction, if we consider the horizontal direction, there is no any force along the horizontal axis. There is no any force along the horizontal axis. So if there is no any force in horizontal axis, there will be no any acceleration along the horizontal axis. So we can find the time very easily. That's the time will be uh, distance upon speed. So what's the distance? Horizontal distance. We are interested in horizontal distance. So horizontal distance is y naught. Speed, we already calculated this. This was the horizontal speed, as we see. So this horizontal speed will be still maintained, right? So we can write this 2e v naught upon m of e. Please note it down. So this is the time duration. In this time, electron will cover this horizontal distance y naught, this vertical y naught also. So now we have to calculate the magnitude of this E. See, this E, electric field, is responsible for downward force, right? This downward force will create downward acceleration. So can we find the downward acceleration? Yes. So now we are going to find AY. So AY will be force of y upon mass. So force of y will be QE, that's this QE upon m, that is the m of E. So this will be the downward acceleration, right? Since I am already saying that it's a downward acceleration, so I don't need to put a minus sign here because I'm already indicated in the diagram also. I'm saying also this is downward acceleration. So this is the acceleration in downward direction. Now, how much distance traveled in vertical direction? It's a y naught distance, right? As you can see, it's a y naught distance in vertical direction. So can we apply, what was the initial velocity in vertical direction? Initial velocity, that is the u. Initially vertical velocity will be 0 because electron was coming horizontally, so there was no any vertical speed. So can we apply the distance in vertical direction? Since this is an accelerated motion, so we have to use now s is equals to ut plus half at square, right? Since we are interested in y axis only, so we will replace these with y substitution. So s of y, that is the y naught, u of y 0 plus half a of y, that is the this E upon m of E into t square. We also know the t square value. We are interested in value of this E. Let me put, so 0 is equal to half E upon me and t square. What was my t? I have the value of t also. So my t was y naught upon this. So my t was y naught upon, what was this? Let's see again. Y naught upon under root 2 ev naught upon m. Under root 2 ev naught upon m of e. And we have to do the whole square also. So see, y naught is equals to half e upon m of e, this y naught square upon 2e v naught, this me goes upside, this will cancel out, one y naught will cancel out, one e will cancel out. So from here we can find the value of this electric field E. This will be 4 v naught upon y naught. So from here we have calculated the magnitude of E. I hope you understand the calculation and concept in this question. Let us see the next question. Indicate the direction of electric field. We have already found it. It is saying to the left, to the right, towards the top of the page, towards the bottom of the page, into the page, out of the page. So according to our previous discussion, it should be towards top of the page. So we will tick on this towards the top of the page. Calculate the potential difference between the two plates required to produce the electric field determined in part B. Now we have to find how much uh, potential difference required to produce this electric field E. See, let us see in the diagram. We get the value of E here as what was the value? That is the 4 v naught upon y naught. This is the electric field in this region, and that's a constant electric field in this region, and the distance between the plate is d. As we know, E is equals to, what is the E? E is equals to v upon d. As we know, E is equals to v upon x. So E is equal to, we can write here the distance is x. So what will be the v? V will be E times of d. Again, I am saying that electric field is constant, so we can apply this formula directly. So E is 4 v naught upon y naught, and d is my d. I can keep my answer in d because d is a given constant. So I think this is the answer, 4 v naught upon y naught times d. So students, we have completed this question. I think there is no any question. Yes, more. So we have completed this question. So if you have understood this question, please like this video and subscribe this channel for such a next question for your AP Physics 2024 preparation. Thank you. Thanks for watching.